Okay, we are on to something called the dropped object formula. And that's a formula that takes into account gravity. And if you dropped something without any wind resistance, how long would it take to hit the ground? So I know outside we have wind resistance. If we dropped a feather, it's going to take a little bit. But this equation does not take into account wind resistance. So everything that we're doing today is going to be a formula that you will learn again, I believe, in physics, that will talk about how long it will take something to actually drop if you didn't have any wind resistance. And that formula is going to be the same formula over and over again for today and tomorrow, and I think the next day. It's negative 16t squared plus vt plus s. So the pieces of that formula, h stands for my ending height. So normally this ending height is going to be the ground, so that's where it's going to be 0 for the most part. T is my time in seconds, and that's what I'm usually solving for. So that's what we're always looking for all these problems. They'll give you all the other pieces except for t. That's the variable that would normally be like our x variable. V stands for my initial velocity. And today we don't even have to worry about initial velocity because we're dropping things. If we threw things, then we'd have an initial velocity, and that will be tomorrow, where we'll start that. And then S stands for my starting height. So that's how high all these dropped things are going to start from. So if we were to take a look at this example that's in the upper right corner here, it says you're on top of Lake Park and you drop a tennis ball. The height of the building is 26 feet. How long did it take to hit the ground? So if we were to label these pieces, the ground is my 0. So my ending height is 0. My time is the one thing that it's asking for, so I do not know that yet. My initial velocity, like I said, for all these, it's going to be 0 due to the fact that we're not throwing anything, we're just dropping it. And then my starting height was the 26 feet. So if I put all of that together, I'd get 0 for my h equals negative 16t squared plus 0t plus 26. So that takes into account my velocity, my starting height, my ending height, and the t I leave there because that's the one thing we're solving for. And that 0t in the middle will always disappear today because we don't have an initial velocity. So it really looks like this. 0 equals negative 16t squared plus 26. So now for all of these dropped object formulas, when we're solving, we can solve by square roots. That's what we learned last week, where you move the t squared to the other side. So if we move the t squared over to the left side, we'd get, now we get 16t squared is equal to 26. We can divide by 16. And now we get the t squared by itself. And we learned that in order to get t by itself, we're going to have to do something to both sides because that t has a squared attached to it. And the thing that we do to both sides is take the square root. So in our calculator, we're going to always just punch in that fraction. So it'll be, I'll move that over for you. It'll be second square root. And then we do that fraction that we see. So it'd be 26 over 16. So I just did 26 divided by 16 in the calculator. And if you press enter, you should get a decimal. And this decimal will be your time in seconds. So it looks like if we rounded 2 decimal places, we'll get 1.27. So t equals 1.27, and that's seconds. And it asks you to write it in a sentence. So it takes the ball 1.27 seconds to hit the ground. So that would be a good sentence, something simple. So that's how we do it. That's how we're going to do all of these. So for this next one, it says an acorn fell from 45 feet. How long will it take to hit the ground? So my ending height, again, is 0 because that's my ground. My time is the one thing I'm solving for, so I'm not sure what that is. I don't have an initial velocity, and my starting height is 45. So if I set this whole equation up, it'd be 0 equals negative 16t squared plus 0t plus 45. I know that I can drop that 0t in the middle. So now I just really have negative 16t squared plus 45. I move that 16t squared over to the left side by addition. Just doing some solving now that we learned first semester. We divide by 16. And now I do the solving by square roots, which we learned this semester, last week, I believe. And then we just got to take the square root. So if we take the square root of 45 divided by 16, let's see what we get. Second square root, 45 divided by 16. We press enter, we get a decimal. So that acorn's a little bit higher than the tennis ball, so it takes a little bit longer, right? So that'd be 1.68 if we round it correctly to 2 decimal spots. And that would be my answer for how long it takes the acorn to hit the ground. Pause if you need to here to write it down. I'm going to keep moving. 2. Vivian fell from an airplane at 32 feet from the ground. How long will it take her to reach the ground? Well, hopefully her chute opens, but if it didn't, this is how long, okay? So her ending height is 0. Her time is the question mark. Her velocity is 0 because she wasn't thrown out of the plane. And she started at 32,000 feet. So now this will be 0 equals negative 16t squared plus 0t plus 32,000 feet. It's kind of a morbid problem. 0 equals negative 16t squared plus 32,000. We move the 16t squared to the other side. So now we'd have 16t squared on the left, 32,000 on the right. We divide by 16. We leave it as a fraction. And then in the end, that's exactly what we put into our calculator. So let's see how long it would take to hit the ground from way up there. So we go second square root, 32,000 divided by 16. And we get 44.72 seconds. 44.72 seconds. So that's a good amount of time it takes to fall from that high. All right, number 3. It talks about a piece of moon. Oh, it's way up there. Falls from 288,000 feet. How long will it take for the piece of moon to hit the ground? Okay, so my ending height is 0. My time, I don't know. It wasn't thrown, so it's 0 for your velocity. And your starting height is 288,000. So now we have 0 equals negative 16t squared plus 0t plus 288,000. The middle would disappear because 0 times anything is still 0. So it's gonzo. I move that 16t squared by addition over to the other side because that's the opposite of subtraction. So now I get 16t squared is equal to 288,000. I divide by 16. And that's what I put in my calculator for under the square root. So I have to take the square root of both sides in order to get t by itself. So now if you were to do second square root, 288,000 divided by 16, 134.16, 134.16 seconds is my answer for number 3. And the last one talks about a box falling from 200 feet. So my ending height's 0 because it's asking, oh, never mind. It says, how long will it take to hit your car, which is 5 feet high? So my ending height's 5. My time, I don't know. It's not a thrown object because there's no velocity. So that's 0. And then it's 200 for my starting height. So now I'd have 5 for my ending height is equal to negative 16t squared plus 0t plus 200. I like this one. So now we have 5 equals negative 16t squared plus 200. I would move the 5 over to the 200 before I move the 16 to the left. So now I have 0 equals negative 16t squared plus 195. And now I'm going to move the 16t squared. That way all the constants are on one side and your variables are on the other for when we solve. Now divide by 16, and that's exactly what we would put into our calculator when we take the square root of both sides. We'd put in 195 divided by 16, and we're going to get some answer out for my number of seconds. So let's see, second square root, 195 divided by 16. 3.49. So that'd be 3.49 seconds. And that'd be your answer for that one. So that's all we got. I'll see you guys tomorrow. Have a great day.